going to be in 6-1. And so we're going to be looking at what's called systems of equations. And basically what that means is we're going to have 2 equations that we're going to graph now instead of just one. And our goal is to find out where do they intersect or where do they cross at. Okay? So, systems of equations. Let's take a second and write that definition down. A set of equations with the same variables. A set of equations with the same variables. Okay? And so when we say set, we're going to primarily work just with 2 of them, 2 equations, but you could have more than that, okay? So on the first example here, what I'm going to do is I'm going to just, to help us out a little bit, I'm going to color code so that we are talking about the same equation, so we don't get confused, okay? So on the top one there, I'm going to make it red. Now, how do I graph negative x plus 2? Emma, you're up here first. Negative x plus 2.
You start 2 on the y-axis.
Okay, and then what?
And then you go down 1 and right 1.
Very good. All right, let's go ahead and start graphing. We need lots of points. It's going to be really important today that we are very precise, at least as precise as we can be, with our hand sketches. Okay? So lots of dots there, and then get me a good line all the way across. Okay? Now we're going to graph the second equation now. We're just going to put it all on the same grid. Okay? So now I have x plus 1. Okay, Tatiana, how do we do x plus 1? Good. And then what do you do with the slope? Very good. 1 over 1. Okay. So like I said, I got that second line, so my blue line here. Okay, again, lots of dots. Use your rulers, be as precise as you can on this. Okay, these 2 lines here are called intersecting lines. They are crossing, right? Okay, so they are called, over here in the 3rd column, we're going to put intersecting lines. Okay, intersecting lines. And on this particular problem, how many solutions are we going to have? How many times do they cross? Just once, right? Okay, so the 2 lines meet in one spot. So we're going to have 1 solution. Okay, intersecting lines, 1 solution. Okay, so now when we have 1 solution, we do have to say where does it cross. Okay, so when I'm looking at this right here, okay, where the red and the blue meet, so right in there, what do you think this coordinate point is? And we're just going to have to estimate, because it's not exact.
1.3. Will it always be 1.3?
We, on our graphs, it'll usually be whole numbers, okay? If it's not, you're going to estimate it the best you can. Next week, I'm going to show you how to get it exact, how we get it precise, okay? And I'm going to show you a math way of doing it, like without, okay? Now, with that being said, we could get precise on graphing if we use technology, right? If we use a graphing calculator or an iPad, some sort of technology, then we could get the exact solution every time. But since we're hand sketching, it's going to be an estimate. Okay, so about where is this coordinate point at?
1.3.
1.3 would be out here, right?
Point
0.3.
Point three.
And 1.5.
And 1.5. I was going to call it 0.5 and 1.5, but if you don't want to call it 0.3, that's fine too. All right, it's about halfway-ish.
Not halfway.
Just put down something. You put down 0.3, I will put down 0.5, okay? All right, so I'm going to call it 0.5 and 1.5, okay? So we need an XY coordinate point. Okay, so 0.5 and 1.5. Okay, does that make sense? So x, y. Okay, 1 solution because it crosses 1 spot. All right, does anybody have a question for me on that one? You okay? All right, so now we're going to go down to the next one, and let's try the next one here. Okay, again, I'm going to color code just to help us out. Okay, so the first one I'm going to make that guy red. All right, we've got negative x plus 2. Alright, Emmanuel, negative x plus 2, what are we gonna do there?
Start at 2,
And then what?
down 1, right 1.
Good. Okay, again, use lots of points there. Okay, and then we're gonna have to do, I'm gonna make the blue one again on the second one. Alright, Ellie, what are we gonna have to do on this guy before we can graph him? Okay, and how are we gonna do that? Good, so we're gonna have 3y equals negative 3x minus 3. Now what do you wanna do?
Let me divide the 3.
Good, that's all right, good, so divide by 3. All right, so when you do that, what'd you end up with? Good, very good. Now, negative 1x or negative x, we know that those are the same thing. All right, minus 1. All right, so let's go and graph that. Quentin, how are we gonna graph that? What's that gonna look like?
Down, -1, and up, down,
It'd be up if it's a negative?
down.
Yeah, okay, so you're gonna go down 1 over 1, down 1 over 1. You'll teach him. If you come back, maybe last like 5-10 minutes, I can help. Okay. All right, so down 1 over 1, here we go. Okay, all right, now, what do we see about these lines here?
Parallel.
They're parallel. Okay, now, without looking at the graph, if I was looking at these equations, how would I know these are parallel? What tells us something is parallel? Peyton?
In the same direction,
Same direction, but what are the
Oh.
equations?
Oh.
Do you remember?
Same
It's okay.
slope.
What do you got, Val?
Well, I don't know about the equation, but
Same slope.
Say what she's saying.
Same
Slope.
slope.
Same slope. There we go. All right. So they're same slope. Now, Malcolm, what were you getting ready to say?
I'm gonna say like, there. If you go from like a red dot, you can go 2 down, and there's a blue dot.
Okay, yeah, so you're saying it's the same distance
Yeah.
apart all the way through, and he's right, okay? But if I'm looking at the equations, I have the same slope on both of them, don't I? Okay, different start positions, but the same slope. That's how I know they're parallel. Okay, so if we have parallel lines, okay, now someone tell me, how many times are they gonna cross or intersect if they're parallel?
None.
Okay, so what do you think your answer is gonna be? That's right. No solution. It's never ever gonna cross, so it's gonna be no solution. So now next to your grids here, just like we put a coordinate point, because they crossed once, we're just gonna put next to it no solution. Alright, so we know that there's no answers there. There's nothing that's gonna work for both. Okay? Alright, let's go down to the third one now. Now guys, on the third one, I'm gonna use some common sense here. Do you guys see how this second equation and this second equation are the same thing?
Yeah.
So I'm not gonna take time to resolve it. Let's go ahead and just call it y equals negative 1x minus 1. Alright, so that's gonna be my blue line. Is everybody okay with that? Yep, okay. And then we've got my top line. Alright, so now with that being said, what do you guys notice about my two equations here?
Same slope.
Same slope.
Same slope? What else you got?
Same
They're the same equation, right? If I'm looking at this, are they not identical when I solve it? Am I not getting the same thing? So let's go ahead and graph it real quick. So if I'm graphing the red line, how are we going to graph that? Chloe, start us off.
You start at -1.
Good. And then what are you going to do?
You go down 1, right 1.
Very good. Down and right. So let's go ahead and take a second, get that done. And use your ruler, get a line for me. Alright, and then if I took time to go ahead and plot the blue, would the blue not just sit right on top of the red? Because it's the same thing, right? So then I would sit here and I'd put the blue on top. It's not the best, but you get the idea. And it's going to look like on your graphs, it's just going to look like one line, right? Because it's the same thing. Now with that being said, how many points match up here?
All reals.
All of them. Okay, it's not all reals, it's the same concept. Okay, but we have a different word. We're going to say infinitely many solutions. Infinitely many solutions. So there's an infinite number of solutions that work here. Okay? So all real numbers say that all numbers will work, but we know that these numbers here don't work, these numbers here don't work. It has to be on that line. Okay? So, off the side here, same line. Okay, and when it's the same line, infinitely many solutions. Okay, infinitely many solutions. Now, with that being said, so next to our graph here, I would let you just put IMS, okay? You cannot put like the infinity symbol or all reals, okay? Because that's not what those mean. IMS for infinitely many solutions, okay? All right, I want you to flip over on the back side once you get that done, and I want you to skip down and look at number 5, and I want you to try number 5 on your own. So it's just like what we did on the front side, okay? So number 5.